Have you ever wondered how jet engines are made? They are, without a doubt, one of the most sophisticated pieces of machinery ever invented. A jet engine is a powerful contraption, a marvel of human engineering that powers our flights across continents and oceans. At its heart, it's all about sucking in air, compressing it, igniting it with fuel, and then blasting it out the back to create thrust. This process, while it sounds simple, is executed in a mind-bogglingly complex piece of machinery that's built to withstand extreme conditions, all while keeping us safely airborne. The jet engine, born from the brilliant minds of pioneers like Sir Frank Whittle and Hans von Ohain, has revolutionized aviation. It's transformed the way we travel, conduct business, and connect with people around the world. A single jet engine can generate enough thrust to lift a fully loaded passenger plane off the ground. That's the equivalent of lifting 70 elephants into the sky, a feat that's nothing short of awe-inspiring. The key components of a jet engine, namely the turbine blades, compressor blades, and casings, are all integral to its operation. The compressor blades suck in and compress the air. The combustion chamber ignites it, and the turbine blades harness the energy from the heated, expanded air to keep the cycle going. Each of these components is manufactured with precision and care, using high-strength materials and cutting-edge techniques. But how do we go from raw materials to a fully functional jet engine? The process is an intricate dance of design, manufacturing, assembly, and testing, all under the watchful eye of rigorous quality control measures. From the initial CAD designs to the final certification, every step is vital in ensuring that jet engines are reliable, efficient, and safe for use in aircraft. The process of making a jet engine is a marvel of engineering, involving a series of meticulous steps. Ready to learn about them? The journey of a jet engine starts on a computer screen, with engineers using computer-aided design, or CAD, software. This digital blueprinting allows for precision and flexibility. Here, the magic begins. It's in this phase where engineers take into account various factors that will determine the engine's overall performance. First, they consider efficiency. How can the engine provide the maximum thrust with the least amount of fuel? This is a question of balance and optimization. Next, they look at thrust. Simply put, how powerful does the engine need to be to propel the aircraft forward? Weight is another critical factor. The engine needs to be light enough for the aircraft to lift off the ground, yet strong enough to withstand the rigors of flight. Lastly, durability comes into play. The engine should be able to withstand considerable wear and tear, ensuring it will serve its purpose for a long time. Once the design is finalized, the next step is selecting the materials. In the world of jet engines, not just any material will do. In the sphere of jet engine production, the material selection is a critical factor. The materials need to withstand extreme temperatures, resist corrosion, and be lightweight yet robust. It's a demanding list of prerequisites. Titanium, for instance, is a material that ticks a lot of these boxes. This metal is known for its high strength-to-weight ratio, which makes it ideal for parts that need to be both lightweight and resilient. It exhibits exceptional resistance to corrosion and can withstand high temperatures, making it a popular choice for components like compressor blades and casings. Next, we have nickel alloys. These materials are incredibly resistant to heat and wear, which is why they're frequently chosen for turbine blades. These blades operate in scorching conditions and are subjected to immense forces. Therefore, they need to be made from a material that won't easily warp or degrade. Composites, on the other hand, are a newer innovation in jet engine technology. These materials are composed of two or more distinct substances, which when combined exhibit properties superior to those of the individual components. Composites are typically lighter and more resistant to damage than traditional materials, making them a promising choice for future engines. Now, let's shift our focus to the manufacturing process. Each component of a jet engine, from the smallest bolt to the largest casing, is manufactured separately. Techniques like casting, machining, and even three-dimensional printing are used to shape these materials into the necessary parts. Casting involves pouring molten metal into a mold, while machining is the process of cutting away material to create the desired shape. Three-dimensional printing, the newest of these techniques, involves adding material layer by layer to form a part. Each technique has its advantages and is chosen based on the properties of the material and the specific requirements of the part being manufactured. With the components manufactured, it's time to assemble the engine. This is where precision comes into play. Each component must fit perfectly. In the world of jet engines, the assembly is an intricate ballet of parts and pieces, all choreographed to come together seamlessly. Skilled technicians, the maestros of this mechanical orchestra, take center stage, carefully fitting each component to its rightful place. Every turbine blade, every compressor blade, every casing, all manufactured separately, now find a home within the structure of the engine. The assembly process is a testament to the meticulousness of the design, where every element, down to the smallest bolt, has a specific role and a designated spot. The stakes are high, as even a millimeter's deviation could affect the engine's performance or worse, safety. But assembling the engine is only half the battle. Once pieced together, it's time to put this mechanical marvel to the test. The testing phase is arguably one of the most crucial stages in the engine's journey from design to flight. First up is the thrust test. This test measures the engine's power, the force it generates to propel an aircraft through the sky. It's a spectacle of raw, controlled power, a testament to human ingenuity. Next, we have the fuel efficiency test, a nod to our growing consciousness of environmental impact and cost effectiveness. This test gauges how well the engine converts fuel into usable energy. Durability testing follows, where the engine is pushed to its limits, simulating extreme conditions it might encounter in flight. From icy cold to blazing hot, from sea level pressure to the thin air of high altitudes, the engine must prove its mettle. Safety, of course, is paramount. Safety tests are rigorous and uncompromising. They check for any potential flaws that could compromise the engine's integrity during flight. Through assembly and testing, we ensure that the engine is not just a collection of parts, but a well-oiled machine ready to take to the skies. But the job isn't done yet. Quality control is up next. Quality control is not just a phase, but a constant presence throughout the manufacturing process. Now let's delve into the meticulous details of quality control and certification in the world of jet engines. Quality control is truly the unsung hero of the manufacturing process, ensuring that each component is up to strict standards and specifications. It's an ongoing process, with checks at every phase of production. From the raw materials selected to the final assembly, each stage is rigorously monitored and evaluated. Precision is the name of the game here. For instance, each turbine blade, compressor blade, and casing must be exactly as designed, without the slightest deviation. Why, you ask? Even the smallest discrepancy could lead to a significant drop in engine performance and, in the worst case, a catastrophic failure. Now, imagine this. A team of inspectors equipped with advanced tools, meticulously examining each and every component. They're checking for proper dimensions, material consistency, and structural integrity. They're looking for any signs of defects, from microscopic cracks to imperfections in surface finish. But wait, there's more. Once the engine is assembled, it's not ready to power an aircraft just yet. It has to prove itself first. This is where certification comes in. Before a jet engine can take to the skies, it must undergo certification by aviation authorities. These authorities have stringent safety and performance regulations in place that the engine must comply with. This process involves a series of exhaustive tests, from thrust and fuel efficiency to durability and safety. These tests are not just a formality. They're designed to push the engine to its limits, simulating the harshest conditions it might encounter during flight. Only after the engine has successfully passed these tests, proving it can withstand the rigors of flight, is it certified for use in aircraft. So, from the initial design phase to the final certification, each step is a testament to the commitment to quality and safety in the world of jet engines. And that's it. A jet engine is ready to power an aircraft. So, you see, the process of making a jet engine is a meticulous one. From the initial design phase, where engineers employ computer-aided design software to ensure efficiency, thrust, weight, and durability are optimized, to the selection of high-strength materials like titanium, nickel alloys, and composites for different engine components. Then comes the manufacturing of each component. Turbine blades, compressor blades, casings using techniques like casting, machining, and 3D printing. This is followed by the careful assembly of these components, where precision is key for optimal performance and safety. The engine then undergoes rigorous testing, verifying its performance on parameters like thrust, fuel efficiency, durability, and safety. Quality control measures are implemented throughout the process, adhering to strict standards and specifications. And finally, before a jet engine is ready to soar the skies, it must pass the certification process by aviation authorities, ensuring it meets safety and performance regulations. Next time you see a jet engine, remember the remarkable process that went into making it.